Okay, as promised, I'm back to talk about why the polar coordinates to rectangular coordinates and vice versa, why the things that we use to convert them are what they are. In other words, why do I use x equals r cosine theta and why do I use y equals r sine theta? Okay, so first off, we've got, say, I'm going to try to do this by hand, which is probably very dangerous. Probably helps that I'm a geometry teacher. I draw a lot of circles in my life. Still not perfect. But let's say that this is my polar coordinates and I have 2 pi over 4. Okay, and that's where I am. Pi over 4 meaning that's the angle. Okay, so 2 pi over 4, and I'm trying to put that in rectangular coordinates. Okay, basically rectangular coordinates means I basically start ignoring all those circles and I try to figure out how to get it otherwise. But remember that if we think of this angle here as theta, that's theta, right? If the hypotenuse, well, let's just go ahead and put the hypotenuse what it is. I'm sorry, I'm sort of thinking as I'm doing this how I want to say it. But that is 2, because that's my radius. The hypotenuse is 2. Okay? If this is my x value, and that's what I'm looking for, then cosine would be that over 2, because this is the adjacent side and this is the hypotenuse. So cosine of theta equals x over 2. But what was the 2 again? It was my radius. So really in a more generic case, cosine of theta is x over the radius. Now can you see how to get from here to here? If I just multiply both sides by r here, I have that r times the cosine theta will give me x. And same thing here. If this is my y value, it's the opposite side. This is the hypotenuse, so that's sine. So sine theta equals y over 2. But again, I want to be more generic, so I'm not going to use 2. I'm going to use radius. This is my radius. That's what 2 is. So sine theta equals y over r. And if I multiply both sides by r, I get r sine theta equals y. Okay? Now, again, let's ignore the 2, or let me just draw it. Well, I like it where it is. I guess I could draw more circles. Here we go. The more of these I do, the more likely I am to start doing them really ugly, but let's just take a random point. Okay. Remember, this is the radius, right? That's the radius of that circle. Well, if this is my x value and this is my y value, then let's Pythagorean theorem. X squared plus y squared has to equal r squared. That's the same thing as saying that r is the square root of x squared plus y squared. Finally, if I want to try and figure out what theta is, there are lots of ways I could do it, but generally, since we are going back and forth from rectangular to polar and polar to rectangular, we're going to do it in a way that assumes that x and y is what I know. Y is the opposite side from theta, x is the adjacent side from theta, so it's the tangent of theta that would be y over x. If the tangent of theta is y over x, then theta is the inverse tan of y over x. So those are those two formulas, and that's why we use what we use to go back and forth from polar to rectangular and rectangular to polar.